So that was all about what we have seen in the last two classes. Was we have talked about the BFF and we also talked about the BF. Right. Now the next topic in our syllabus is going to be something called as hashing. And we have already discussed in our class that what is hashing. Right. So this is a technique, a small recap. That it is a technique, right? And we have a fixed size table. And what we're going to store, we're going to store the key value pair. So this is typically order of one. So this is very fast in insertion, deletion, and search operation. Also, we have seen some few basic operations. These are the basic operations which we will be doing now, right? And these are the components. We have discussed what is the key, what is the hash function, right? We have also discussed what is the hash table, and when two keys, when there is a collision between two index values, right? How are you going to resolve it? We have seen the, as you know, it is a fixed size array, and we are going to store key value pair in the form of index, right? The form of index. How are you going to get the index? So this is a small example which we have discussed in the class. So suppose the table size is 10. This is the hash function, right? Suppose you have a value is called as 23, right? What does this hash function returns? It returns the index 3. That means we need to store in third index in the hash table, right? Here is a small example of collision. What happens is, given these are the keys 12, right? If you pass 12 to the hash function, what happens? It gives you 2, right? You're going to store it in the hash table of second index. Now suppose it is 25. You get the hash function of what? 5. You store it in the fifth index. Suppose you have 35, right? Now 35 you pass it to the hash function, it returns 5. But already at 5 you have a value. You have a value and key, right? What happens? This is called as collision. There are techniques for collision, mechanism for techniques. To avoid collision, we will see two of them. So definition is given below. Happens when two key map to the same index. So this is a collision, one of the technique called as subnet chaining. We have already discussed in our class, offline class. Now, when there is a key, when you have inserted a key here, right? Now again, you are inserting in the second index. What happens is somehow you create like a matrix. This is going to be 2 of 0, this is going to be 2 of 1, and this is going to be 2 of 2. What you're doing? In the same row, you are storing it in different places, right? So this can be considered as separate chain. Now you have three numbers is good. Suppose you have 300, right? So this becomes almost like more memory. So we are going to see the second one, which is called as linear probing. The linear probing is instead of storing it in one index, what you're going to do, you're going to store it in the next index, which is I plus 1. I plus 1. If this is full, you go to the next one. If this is also full, you go to the next index. Like that, you keep on going. If there is no empty slot, that means the hash table is full because it is a fixed size. Okay, so that is what this function is saying. Hash table of key and index, and hash table of key plus the index size is the hash table of 7, right? This is a hash function. We're going to insert these three values. First one, right, you're going to insert it in 3. It is empty. You're going to insert. Second one at 6, it is empty. You're going to insert. The third element, right, insert. Now, suppose you want to insert again the next value, 20. 24 is already taken. What you're going to do? You want to insert at the next index. The first method is called as chaining, right? We will see the code part. Here you're creating a hash table. The hash table, what you are taking? For the range of 10, you're creating 10 empty lists. How it looks like? It looks like something like this. What is the hash function? Hash function is the fixed number 10. Now this is the next one where you're inserting the key value, right? To insert a key value, obviously if you want to insert, for example, if you want to insert 22 and if you want to insert some value psi, You cannot simply insert in 22. You know that we have discussed that it should be passed to a hash function. This hash function of the key should be the index value. What is the hash function of the key? This is a key. This is a key and this is a value, right? What is the hash function of key? Hash function of 22 is what? It is going to be 2. That means I need to store this value. I need to store this value in the second index. What is the second index? Second index is this, because this is 0, 1 and 2. I need to store it in this list. Okay. Now, the same thing is given here. You pass it to a hash function, right? And you're storing it in a index value, right? Now, if you want to search for a key. Now, if you want to search for a key, obviously, that key should be passed to a hash function. Why? Because you're storing it in the index value, right? Now, for example, if you're searching for 22 again, right? Now, 22 cannot be finded, right? Because you have the index till 9. There is no 22 index. What you're going to do? Again, you're going to pass it to a hash function. And what it returns the second index. That means the value we are searching for is in the second index. Now, since this is a key value pair, right? The key value pair. What is the key value pair? Change the color of. What is the key value pair? The key value pair is this key value pair. Now, for key value in the hash table of index k, if k is equal to the key we are searching for. That means 22 is equal to this value we are searching. Then return the value. What is the value? Value we have. So the output is going to be set. Or else, now suppose you are searching for 99. 99 does not, we don't have anything. Then the list is empty. At that time, what you're going to return? You're going to return none. So this is about the chaining. Yeah. Now next one is called as the linear probing. What is linear probing? I plus 1, right? Suppose you have a collision. At index 3. You move to the index 4. Okay. How are you going to do that? You're going to do that. Now, this is the code you see here. I'm inserting a size, right? And what I'm going to do, I'm going to create a hash table with 10 nuns. I create a hash function. Now, the hash function is going to be what? Key. What is the size? Size is going to be 10. Now, suppose the size is not 10. The size is 7. What is the hash function is going to be? Hash function is going to be this. Okay. Don't be confused on this. Suppose I want to insert the same value here. Suppose I want to insert. What I'm going to insert? I want to insert 2 and I want to insert the value sign. Suppose. What happens here is, what happens to the index value? The index here will be what? The hash function of the key. What is hash function of the key? It is 2. The index will return here 2. So I'm going to take the start index as 2 also, because there should be some stopping criteria. Right? Now, while loop runs from here, while hash table of index is not none. Now let us see this. Hash table of index 2. Is the hash table of index 2 is none? Hash table of index, how it looks like? It looks like this. And second index, third index, and so on. It is going to be till 10. Now, this is the 0th index, this is the first index, and this is the second index. Is it none? Is the second index none? It is not none means, instead of none, there should be a key value pair. If this is the case, then we are going to execute this part of code. Or else we are going to simply insert the key value pair at that index. Now, since it is none, we don't run this part of code. And at index 2, I am going to insert my key value pair 32 and psi. Right. 22 and I'm going to replace this none. Instead of none, I put it here. Now that index is not none. Okay, now the next time if you want to store it index 2, we are going to run this while loop because that is a collision. Let us see that. Now suppose I want to insert 12, right? And I want to insert Venkat. Suppose I want to insert this value. Now what happens is I get the hash index, right? I get the index as 2, right? And I got starting this also 2. Now at the second index, this is not none because in the last time I have replaced the none with this. I have replaced the none with this value. Now since it is not none, right? What am I going to do? I am going to replace the index value 2 plus 1, right? 2 plus 1 is going to be 3. Now the index value will be 3, right? Now since 3, you see here the index value is 3, right? The starting value is 2. Is it equal? No, it is not equal. So we don't run this. Why are we using this is that when the hash function is full, you're not going to insert anywhere. Once you replace the index with 3, you're going to check if 3 is empty or not. Since 3 is none here, since in the index value 3 is none here, I am going to put my this new key value pair at index 3. Like that the same way, I can search for my key value pairs. Now suppose I want to search for key 20. Suppose I want to search for key 22. What is the index? What is the index I'm going to get? The index I'm going to get for 2. Right. Now I'm going to take the start index also here. Right. I'm going to take the start index as 2 again. While hash table is not none. Obviously, when it is not none, right? When it is not none, I'm going to search for it. If it is none, then I'm simply going to return none. Okay, since I have two key value pair elements, which is 12 and which is Sai, and 22, which is Venkat. I have inserted two elements. While the hash table is not none. It is not none. Now, what is the key I'm searching for? The key I'm searching for is 22. If hash table of index 2. Hash table of index 2 of 0. What is 2 of 0? Now, you see here, the moment I store in a form of key value pairs, right? Key value pairs. This is the second index. If this is a second index, right? 2 of 0 is going to be what? This value. 2 of 1 is going to be this value. Now, what am I saying here? The hash table of 2 of 0. The hash table of 2 of 0. Now, what is the hash table of 2 of 0? It is 22, right? And is equal to what we are looking at. If both are same, then return me the index value of the first one. What is the first one here? It is going to be Venkat. Okay,